All right, this is section 8.1, the Pythagorean Theorem. The Pythagorean Theorem in a right triangle is the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. And you guys see this on your paper as a squared plus b squared equals c squared. Now, believe it or not, there are some famous Pythagorean right triangles that are common in geometry. So let's go ahead and write those down. The first is the 3, 4, 5. So 3 squared plus 4 squared equals 5 squared. And just so you know I'm not messing with you. You know that's 9 plus 16 equals 25. That checks. And we have the 6, 8, 9. So if we tested that out, 6 squared plus 8 squared should be equal to 10 squared, which does 36 plus 64 equal 100. You do the math on that and you see, yes, it does. So some other common triples are the 5, 12, 13, the 8, 15, 17, the 7, 24, 25, the 9, 40, and 41, and the 20, 21, and 29. So a Pythagorean triple are any three integers that satisfy the Pythagorean theorem a squared plus b squared equals c squared. So if we look at example 1, we're going to solve for the variable and then determine whether it's a Pythagorean triple. So we take this first one here. We got 5 squared plus 12 squared equals c squared. 5 squared is 25. 12 squared is 144. And the two of those added together are 169. When we take the square root of 169, we get that c is equal to 13. Square root of 169 is 13. The other way we can see Pythagorean theorem is when we're given one leg and the hypotenuse. We look here and 14 is the hypotenuse. So if c is 14, then we have x is a and 7 is b. So it's going to go x squared plus 7 squared equals 14 squared. When we do the math on this, x squared, sorry, I know it's hard to see the green. So x squared plus 49 is equal to 14 squared. And 14 squared is 196. We're going to subtract 49 from both sides, and we get x squared is equal to, if I borrow from the 9, make that an 8, give it to the 16. 16 minus 9 is 7. 8 minus 4 is 4. We get 147. And we look, I'm going to take the square root of both sides, and I'm going to get x is equal to whatever the square root of 147 is. So we need to look to see if there's any perfect squares inside 147. And I think 7 goes into 147, so that is 7 times 21. So that's 7 times 7 times 3, because 21 is 7 times 3. And we're going to go ahead and take this number. 7 times 7 is 49. We're going to take the square root of it. Square root of 49 is 7, and leave the 3 inside. Okay, the next example I have this shape right here. I'm going to split it into a right triangle and a rectangle. When I do that, this little piece becomes, it used to be 16, but 10 of it is taken here, so that leaves 6 of it to go there. I'm going to solve for my height here. So I'm just going to focus on this right triangle. I don't know h. I know my hypotenuse is 10, so we're going to square that. I'm going to square my side and square my height. When I do the math on that, we get 100 equals 36 plus h squared. Knowing my Pythagorean triples, I know that my missing side is going to be 8. But let's do the work just to make sure we are on the right path. I get h squared is equal to 64. Divide both sides, or sorry, take the square root of both sides, and we get h is equal to 8. So now we can find the areas of the triangle, which is 1/2 6 times 8. And we can find this area of the rectangle, which is 8 times 10. So the area of the triangle is 48 divided by 2, which for us was, that's 24, plus 8 times 10, which is 80. 24 plus 80 is 104, and let's put the units squared. So when you're missing the height of a triangle, you can use Pythagorean theorem to find that height. All right, we're going to prove the Pythagorean theorem, so be prepared to get your mind blown. So if we look at, and I'm going to take this little box out, we look at this blue square here in the middle. It is a true square, so its sides are C. So on your paper, put the side length of that square as C. Now we have 4 individual triangles that make up the rest of this shape. The triangles have the same dimensions. The shorter side is A and the longer side is B. So go ahead and put that on your shape, the long and short dimensions for your smaller triangles. So we're going to prove the Pythagorean theorem. We're going to do this by finding the area using the outside dimensions. And then we're also going to do that by finding the area using pieces and adding them together. So if I look at this square here, I can see that the side length for my big square is A plus B. It's just these 2 dimensions added together. I look at it for this one here, and I also see it is A plus B. So when I'm finding the area of a square, I take my side and I square it. Now we have to remember that it is not A squared plus B squared, but we're going to have to FOIL it out. So when we do that, we get A times A, which is A squared, A times B, which is AB, B times A, which is AB, and B times B, which is B squared. You're going to combine these 2 pieces together. So our area is equal to A squared plus 2AB plus B squared. Now we're going to solve this using the pieces. So we have the area is equal to the area of this inside square. Well, the area here is our side squared. And we're going to add that to the area of our triangles. Well, the area of the triangle is 1/2 base times height. And then I look and see, oh yeah, I have 4 of them. So I'm going to add 4 triangles, 1/2 AB. So let's go ahead and simplify that. 4 times 1/2 is 2 AB. So now we can say that the areas, each area should be equivalent. So I'm going to set a squared plus 2ab plus b squared equal to c squared plus 2ab. Then I'm going to subtract 2ab from both sides. When I do that, I get a squared plus b squared equals c squared. All right, so example 4, we're going to draw an isosceles right triangle properly. So let's get our isosceles triangle written down. It is a right triangle. An isosceles triangle has 2 sides equal. So we're going to make that x and x. The hypotenuse is 18 inches, so that goes here. Now we're going to use Pythagorean Theorem. X squared plus x squared equals 18 squared. When I have an x squared plus an x squared, this combines to give us 2x squared. And then 18 squared is 324. That's 18 times 18. Then we're going to divide both sides by 2. And x squared is equal to 162. Unfortunately, 162 is not a perfect square. So we're going to have to simplify the 162. So x is equal to, if we look, 162 is splits up into 2 times 81. So if it's 2 times 81, the 81, we go ahead and take the square root and put it out front. And square root of 81 is 9. And then the 2 stays under the radical. So in this case, the length of the leg is 9 square root of 2 inches. Okay. Example 5. If we have a square whose diagonal is 5, what is the area and perimeter? So if I have, this is a square, so we've got x here and x here. It's a right angle. See? Okay. All 4 sides are x. The perimeter, let's do the area first. The area of a square is the sides squared. The perimeter of a square is 4 times the side. So we really need to know what that side is. So we're going to go, here's your isosceles triangle. We're going to go x squared plus x squared is equal to 5 squared. And just like the problem before, we're going to combine the x squareds together. So we have 2 of them. 5 squared is 25, and we're going to go ahead and divide by 2. So x squared is equal to 25 over 2. Then we're going to take the square root of both sides. And we get x is equal to the square root of 25 over the square root of 2. We can't have a square root in the denominator. So we're going to get rid of that square root in the denominator by multiplying the top and the bottom by our denominator. When we do that, we get square root of 25 is 5 times the square root of 2. And look what happens when we multiply a square root by itself. We get square root of 2 times 2. Oh, that's the square root of 4. Square root of 4 is 2. So we get, when we multiply square root of 2 times square root of 2, we get 2. This is true if we had square root of 5 times square root of 5, that would be equal to 5. If we had square root of 8 times square root of 8, it would still be equal to 8. All right, so now that we know what x is equal to, we're going to take it back here, and we're going to square it to find the area. So it's 5 root 2 over 2 squared, and we know that that's the same as 5 squared. We got root 2 squared, and we got over 2 squared. So we know 5 squared is 25, root 2 squared is 2, and 2 squared is 4. Now we simplify. We have 2 goes into 4 twice, 2 goes into 2 once, and our final answer is 25 over 2, which reduces to 12.5 meters squared. And then the perimeter is 4 times our x value. So it's 4 times 5 root 2 divided by 2. 2 goes into 4 twice, and 2 goes into 2 once. 2 times 5 is 10, and the root 2 just hangs on, and that's in meters. So the perimeter is 10 root 2 meters, and the area is 12.5 meters. All right, so we're going to do converse of Pythagorean theorem. So if the square of the longest side of the triangle is equal to the sum of the squares of the lengths of the 2 other sides, then we can say the triangle is a right triangle. So let's test to see if these examples are right triangles. Does 8 squared plus 7 squared equal 113 square root squared? So this is 64 plus 49. Does it equal 113? That's what we're asking. And when we do the math, the answer is yes. So let's press this. And that is a big fat yes on that one. The second one, does 15 squared plus 36 squared equal 4 root 95 squared? Let's get out our calculator. 15 squared, I know that one by heart, that's 225. 36 squared is 1,296. And when I add that to 225, I get 1,521. Is that equal to 16 times 95? Because 4 squared is 16, and square root of 95 squared is 95. And that's 1,520. Are those equal? That is a big nope, unfortunately. Okay, theorem 8.3, if the square of the length of the longest side of a triangle is less than the sum of the squares of the length of the other two sides, then the triangle is acute. So that goes to stand. Let's write the equation down. So if the longest side, or the hypotenuse, which technically is our c squared, is less than a squared plus b squared. So it's like having a really small c and a long a and a b. So if a squared plus b squared creates a bigger number than c squared, then you are acute. The opposite of that is true if c squared is less than a squared plus b squared. So our a squared and our b squared, oh, I just wrote that. So if our c squared is bigger than our a squared and our b, so it's like having a really long hypotenuse that's not how we draw it. It's having a really long hypotenuse, just up here, and a shorter a and b. Then your triangle is obtuse. So with a real quick check, you can tell whether you have an acute, obtuse, or a right triangle. So let's look here real quick. We've got, so this is our hypotenuse. Make sure you identify that first. So we're going to take a look at, see what 86 squared is, and see how it compares to 38 squared plus 77 squared. And then we grab our calculator. So 86 squared is 73.96. 38 squared is 1,444. 77 squared is 5,929. And that is 73.73. So 73.96 is greater than 73.73. So this one would be, so our c squared is bigger, that is obtuse. So let's go ahead and grab the obtuse. And check that's correct. So we are going to do the same thing. 37.5 is our hypotenuse, so we got 37.5 squared, and we're going to compare it to 10.5 squared plus 36.5 squared. So we get 37.5 squared, 1406.25, and then we get 10.5 squared, which is 110.25, and 36.5 squared, which is 1332.25, which is 1442.5. That is bigger. So when my a squared plus b squared is bigger, that's this scenario here. So we know that this is acute. So let's go ahead grab the acute, and check. That is correct. Last but not least, let's check this one, our 97 squared, and how it compares to 72 squared plus 65 squared. So our 97 squared, 9409. And we have 72 squared plus 65 squared, which is 9409. When it's equal, it's a right triangle. So if we get a squared plus b squared equals c squared, then we have a right triangle. All right. Example 8. You're making the foundation with 4 stakes and string. So we got 4 stakes here, and we got the string that goes around. Got a little rectangle. Is this guaranteed rectangular? Why or why not? So let's go ahead. If it's rectangular, then it makes a 90-degree angle. So let's go ahead and find our diagonal. Is this guaranteed rectangular? This would be a no scenario because it could be a parallelogram. We are not guaranteed this 90 degrees in the corner. So in order to guarantee the 90 degrees in the corner, we need to make sure that the diagonal is a squared plus b squared equals c squared. So we're going to go 72 squared plus 30 squared. Does that equal, the question mark there, 78 squared? Let's get our calculator. We got 72 squared plus 30 squared, and that's 6,084. Does that equal 78 squared? Yes. This is a right triangle. All right. And that's the end of our lesson today.